Hello everyone. Today I'll be showing you a more intuitive approach into memorizing and understanding the different shapes, structures, and angles of the different respective bond pairs and lone pairs. Now on the screen we can see most if not all of the different shapes and angles that we need to know for the A levels, and now I'll be telling you the six most important structures and angles you need to know is this one, this one, this one, this one, and this one. Oops, let's draw a straight line. This one. That's not straight. Right. So basically the ones with zero lone pairs. Now why? Because subsequent with the knowing the ones with zero lone pairs, you can subsequently derive the other respective items under its total number of pairs. Now for the first one, two bond pairs, zero lone pairs, is fairly simple. You can see on the screen here, two bond pairs, zero lone pairs is a linear shape, 180 degrees. That is simple enough. Three bond pairs, zero lone pairs, you have trigonal planar, which is 120 degrees. Now 120 degrees here. Now for bend, what we need to know that for every bond pair we turn into a lone pair, it is minus 100, it's minus 2 degrees. So we have a trigonal planar here, when between its different positions it has an angle of 120 degrees. Yeah, so now what if I take away this part? What if I take away this part? Basically I will then, by the VSEPR theory, we know that the repulsion between a lone pair bond pair is more than a bond pair. So there will be greater repulsion here. It will push both of them in more together. So this one will become a 118 degrees. Yeah? Okay. Then there is the structure of a bend. We can see it's bent. Yeah? Alright. Now let's look at four bond pair, zero lone pair. We have a tetrahedral shape, which is here. You can see a tetrahedral shape. Yeah? So for a tetrahedral shape, 119 degrees, that memorize that, very important. 119 degrees, then three bond pairs, one lone pair, we get a trigonal pyramidal. Now what is a trigonal pyramidal shape? You might ask. A trigonal pyramidal shape is basically a pyramid with a triangle as its base. What do I mean? I take this away. Yeah, this is away, VSEPR theory, same logic. The lone pairs, bond pairs will push more towards in together. So yeah, 117 degrees between here. Now, trigonal pyramidal, let's understand. Trigonal pyramidal, we know a pyramid is like this. From this, you can see a pyramid. Then from this, we can see its base is actually a triangle. So it's called a trigonal pyramidal. A pyramid with a triangle as its base. Then two bond pair, two lone pair. Two bond pair, two lone pair, simple enough. We take away this one, then what do we get now? We get a similar structure to a bend shape. Yeah. And now we look at five bond pairs, zero lone pairs, a trigonal bipyramidal. Now what is a trigonal bipyramidal? Now we know trigonal pyramidal is a pyramid with triangle as its base. Now trigonal bipyramidal, this is also a pyramid with triangle as its base. You see, is a triangle, and it's a pyramid. Bipyramidal, bi means two. So there are two pyramidals. There are two pyramids with a pyramid at its base. You see here? Can visualize? Yeah? Tada. Right. So trigonal bipyramidal, 100. Now what does it mean by 120 degrees along its equatorial position, 90 degrees along its actual position? What this means is this one is 90 degrees. Also that one at the back is 90 degrees. Now where is the actual position, the equatorial position? equator, we know equatorial equator. Axial, we know is axis. So equatorial position is between here. This one is 120 degrees. This one here 120 degrees, 120 degrees. Then this one is actually very simple to memorize because this one is just a square. Nope, it's not a square, it's a trigonal pyramidal. No, it's a trigonal planar. What I'm talking about? Funny. Not funny, ha. Okay. What's this? Right. Now, then from trigonal pyramidal, how we can deduce a seesaw shape? What is a seesaw shape? A seesaw shape, we take out this one, then we suddenly get this one. You see? We get out these ones, then get this one. How is this a seesaw? Why got seesaw like this one? This is a seesaw. You got no childhood. This is 100% a seesaw. Let me show you. Let me show you how this is a seesaw. This one, whoop, boom. This one seesaw. One person sitting here. One person sitting here. The two ball at the bottom is just just to hold his weight. Then do seesaw, 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 seesaw. You see? Seesaw shape. I'm telling you, seesaw shape. Then seesaw shape, right? The 120 degrees they don't have. Why? Why this one? Why along the equatorial position is less than 120 degrees? Because imagine this is along its own plane, along its equatorial plane. It will only affect the equatorial plane right now. But the actual position is still maintained. So this one is still 120 degrees. 120 degrees along its actual position between its axes. But this one now is less than 120 degrees. Yeah? It's the same logic as the trigonal planar become bent, but it's not bent. Then why it's not 118 degrees? Because of the other two bubble at the back. They got some interaction, you know. Right. Now let's look at T shape. What is T shape? T shape is T pose lah. So easy. You got play Fortnite or not? Got no childhood This one is T. You see T shape? Then T shape need to be careful People say T like this What? T like this 90 degrees, right? No. T shape is less than 90 degrees. Is less than 90 degrees. Less than 90 degrees. You know? Less than 90 degrees. Okay? Yeah, I'm telling you less than 90 degrees remember Now this one 2 bone pair, 3 lone pair. You take this one out. Then 180 degrees down low. Easy. In it fam. Visualize. Must visualize You take this one you put slowly like this, then you put slowly like this, then you put, then you 答辩出来 you got the answer you get good marks, you know. Yeah. Now let's look at octahedral. Why is this called octahedral? Why is this called octahedral? Because it look like an octopus. You know how I know it look like an octopus? This one boom boom bam bam, then bam bam. Octopus. Octopus they say got 8 legs but I disagree, you know. The octopus in my country got 6 legs. So this one is octahedral, you know. So octahedral 90 degrees. Everywhere along its axial position. Everywhere along its axial position. Everywhere along its axial position is 90 degrees. You know? Okay, very good. Now let's look at the square pyramidal. Wow, square pyramidal become like this You take this one away, boom 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 boom. Then less than 90 degrees already. Why Why less than 90 degrees? You take this one away, right? Then this one very sad. Then very sad then they crying, you know. Crying. You see the tears? You see the tears flowing down? Become less than 90 degrees. A lot of tears, you know. Okay, less than 90 degrees. Then this one they want 90 degrees again. So this guy commit suicide, you know. Commit suicide. Then 90 degrees. Then the rest of the people happy already now. That sounds very morbid. But no, these people are terrible. Terrible people. Terrible people. This guy died already. Then we get back our 90 degrees. 90 degrees like this Then this one 90 degrees. Very same logic. Same logic as this one. You ask why T shape is less than 90 degrees? Because this one is 90 degrees. You take this away become lone pair, boom boom, repulse more, less than 90 degrees now lor. You know? So this is an intuitive approach on how to memorize the stuff. Bye bye.